And that's it. I'm not going to put up with this anymore. You're in detention, buddy. Yeah. You're going to go over, cast yourself over to the Amazon Fire tablet. You did this, not me. Listen, I know it's slow as hell, but you'll think twice before you act like this again next time, won't you? Enjoy your 240p. Guys, you got to calm down. I can't teach with you just interacting like that. I'm gonna have to do a seating chart. I think this is the only way it's gonna work. All right, and there. I didn't want to do it, but you made me. All right, John, you're gonna look that way, and then Misha, you're gonna look that way, and then that way. All right. I've been wanting to do this for a while. All right, ready? Go. Here's the story of a lovely lady who was bringing up three very lovely girls. It's just like I imagined. Okay, for number 7, I think we're going to go ahead and multiply by 13. And Daniel, no, we don't talk sports right now. The Bucks would never get Brady. Are you serious? Are you serious? The Bucks, Tom Brady. If you're lying, I'm going to fail you. If you aren't lying, I'm failing everybody. Yeah, well, maybe if you weren't so lazy, things might be getting done around here. All right, guys, just click on the bullying prevention lesson. Let's go ahead and get started.
What's up, you guys? We're in our second day of the wardrobe theme for the week, which is monochrome for coronavirus. So I am wearing everything, just different shades of blue today. Today we're going to talk about valence electrons in atoms, what they are, how to tell how many an atom has, and what they determine about an atom. I'm going to take you through that, and then at the end, I'm going to give you some details on your assignment for the week. So we're in our unit about the periodic table. And one of the most important things that you can learn from the periodic table is the number of valence electrons that an atom has. And the number of valence electrons is going to explain so much about an element, right? How many bonds it will form, how reactive it is, those sorts of things. As kind of an introduction here, I have kind of an interesting study that was done a few years ago. So they did a study and they looked at what is the factor that most influences a judge's decision to give bail, right? Like, will judges grant bail based on the amount of time the person has been in prison, or if they've had previous offenses or something like that? And they found that the number one thing that influenced the ruling of judges was whether or not they had had a snack. So the judges tended to rule more harshly before lunch, and they tended to be more merciful after lunch. It's kind of like that Snickers commercial, right? Where you're not you when you're hungry. The lesson here is that if you are hungry, it can change your behavior and even your decision-making capabilities. And the reason why I show this to you is because the same thing is true of atoms. The behavior of an atom, like how reactive it is or how many bonds it forms, depends upon how hungry it is. And what is it hungry for? It's hungry for something called valence electrons. Now, valence electrons are the electrons on the outermost energy level of an atom. So take this example here with carbon, right? This carbon atom has 6 protons and 6 neutrons, and it has 6 electrons, but understand something. 2 of them are on this short or on this closer energy level, and 4 of them are on the outer energy level. So how many valence electrons would this carbon atom have? And the answer, of course, is that there are 4 valence electrons. Okay? Because if we count here, right, 1, 2, 3, 4. There's 4 electrons on the outside of this atom, so therefore there are 4 valence electrons. Now notice, there are 6 total electrons here, right? That doesn't change. But remember, valence electrons are only the electrons that are on the outside of this atom. So, how can you determine the number of valence electrons that an atom has? Well, I have made this new periodic table available to you on Google Classroom, and what the number of valence electrons has to do with the group number that an atom is in. So you'll notice this purple box here. If an atom is in group 1, it has 1 valence electron. All of these atoms here behave similarly because they all have 1 valence electron. All of these guys in group 2 here, they have 2 valence electrons. They have 2 electrons on their outermost energy level. Now I'm going to skip over this stuff in the middle. You don't need to worry about it. But over here in group 13, all of these atoms have 3 valence electrons. In group 14, they all have 4, 5, 6, 7, and 8. So this group 18 here, clear on the right, they have 8 valence electrons in their outermost energy level. Neon has 8, argon, krypton, stuff like that. All right, so you are free to use this for any assignments that I give you. So, one of the things that we do with the valence electrons of an atom is we draw the Lewis structures for that atom. And so the way that we do that is we write the element symbol. Now I'm going to just make an A here. A is not an actual element. I'm just going to do this as an example. A doesn't exist as an element. But what you're going to do, if I ask you to draw the Lewis structure for a certain atom, what I'm asking you to do is I'm asking you to write the element symbol, find the number of valence electrons, and then draw them as dots in the correct order. Now there's an order that you do this, and the order goes like this. You put your first dot here, your second dot here, third dot here, fourth dot here, fifth dot here, sixth here, seventh dot here, eighth right there. So you only put 1 dot on one side at a time, right? And it's pretty important that you do it in that order, okay? So the order that you put the dots on are 1, 2, 3, 4, 5, 6, 7, 8. All right, so we're going to do a couple of examples here. What would be the Lewis structure for carbon? Well, first thing we would do is we would write the element symbol for carbon, which is a C. Then we would find the number of valence electrons. And if we look over here, carbon happens to be in group 14, which means that it has 4 electrons on its outermost energy level. It has 4 valence electrons. Now, I would go ahead and put those down in order. I would put a 1, then a 2, then a 3, then a 4. And that is the Lewis structure for carbon. That's all you have to do. 1, 2, 3, 4. Each of these dots represents a valence electron. All right, let's do another one. This is for chlorine here, okay? Chlorine, Cl. So the first thing we do is we'd write the element symbol, Cl, find the number of valence electrons for chlorine next. And what we would do is we would look in where chlorine's at. Chlorine's right here. It's under group 17, which means that there are 7 valence electrons. And I'm going to go ahead and write that down here. There's 7 valence electrons. So I would put those valence electrons on in the correct order. I would go 1, 2, 3, 4, 5, 6, 7. So notice that there's 1 electron by itself. So this is what the Lewis structure for chlorine would look like. Now, earlier I mentioned that atoms behave depending upon how hungry they are. And the thing that they're hungry for are valence electrons. Now, the most important thing to understand here is that atoms are not just hungry for any number of electrons. They want 8. That is what they want. They want to have 8 valence electrons in their outermost energy level. So that's the Octet Rule. Atoms are the most stable when they have 8 valence electrons. Once they get 8 valence electrons, they become way more stable. They don't react nearly as much. They just kind of chill. They don't do chemical reactions really. They just kind of hang out. Okay. Now, an atom might do several things in order to get 8 valence electrons. For example, an atom might gain valence electrons, like up here, right? Oxygen is gaining, it's pulling in 2 more electrons to fit into it. It might choose to lose electrons. So for example, sodium only has 1 valence electron. If it loses 1, that means its next highest layer has 8, right? So like sodium might lose an electron, but sometimes atoms might form bonds. And so that allows them to gain valence electrons. Like these 2 chlorines here, they are sharing these 2 electrons, valence electrons in the middle. Because valence electrons are the electrons that atoms use to bond. So, like I said, in order to get 8 electrons, or 8 valence electrons, atoms might gain 1, lose some, or they might form bonds. So, we can use the Lewis structures of an atom to figure out how many bonds an atom will make. So, carbon, remember we learned before that carbon has 4 valence electrons. But understand something here. If it has 4 valence electrons, that means that it has 4 open spots here. Right? Because there's 8 spots total, 4 of them are filled by valence electrons. So, the question is here, how many bonds will carbon make? And the answer is that carbon will make 1 bond for every space it needs to fill. So that means that carbon is going to make 4 bonds, right? Hopefully that makes sense. In order to fill these 4 spaces and get to 8 valence electrons, because that's what carbon wants, that's what all atoms want, to get 8 valence electrons, they will make 4 bonds. Okay, so when you draw the Lewis structure, you can just look at however many empty spaces there are, and that will be how many bonds it'll form. Let's do another example. So this one is how many bonds will nitrogen form? So let's look up nitrogen. Nitrogen is under group 15, which means that it has 5 valence electrons. So let's make that Lewis structure. We go 1, 2, 3, 4, 5. Now that we have our valence electrons, let's look at the places where it has open space. It's got 1 open space here, 1 open space here, and 1 open space here. All right, so how many bonds will nitrogen form? Well, the answer is it'll form 3 bonds, because there's 3 open spaces. It already has 5 valence electrons, but if it got 3 more, then it would have 8. That's why it forms 3 bonds, right? One of the most common molecules on Earth is nitrogen gas. It's the gas that's in the atmosphere. And nitrogen gas is just 2 nitrogen atoms bonded to each other, but it has 3 bonds. And so now you can see why nitrogen gas has 3 bonds, because there's 3 open spaces. It needs 3 more valence electrons in order to get to 8. Let's try this one. How many bonds will sulfur form? Well, first of all, let's look up the number of valence electrons it has. It has 6, it's in group 16, so it has 6 valence electrons. So let's go 1, 2, 3, 4, 5, 6, and that's it. All right. Where are the open spaces? Well, there's 1 open space here. There's 1 open space here. And so you should be able to figure out by now that sulfur is going to make 2 bonds typically. Because if it got 2 more electrons to put in these spots, then it would have 8. All right. So this brings me to the assignment for the week. So here I'm giving you kind of a problem, and it has to do with welding. Okay, so in welding, a lot of the times you have an arc, right? And you're using it to fuse two pieces of metal together or something like that, right? But a lot of the times what'll happen is they will actually pump a shielding gas into that area, okay, into the area of the weld. And the reason why they do that is they do it to protect the weld because they don't want any reactions happening here with the air, right? With the oxygen and stuff in the air. You don't want the weld or anything like that to come into contact with stuff in the air and react with it. So they pump out this gas, and this gas kind of surrounds the weld, and it the keeps the weld clear of anything that might contaminate it. Okay. Now, here's my question. Many times they will fill this shielding gas with argon. Okay, with argon gas. Now, here's my question. I want you to figure out why they use argon gas. Why would they do that? Why would argon gas keep unwanted stuff from reacting and getting in here? Okay, so the first thing you're going to do is you're going to figure out how many valence electrons argon has. Then you're going to draw its Lewis structure, figure out how many bonds it wants to make, and then based on that information, make a claim, make a hypothesis. Why do you think argon is a good gas to put here? Why not put oxygen or some other gas that we might use? What you'll do is you will do all of this on a separate piece of paper and upload a picture of that piece of paper to Google Classroom. There's more information in the assignment itself. But the one thing I want to leave you with here is that the purpose of the gas is to keep reactive things away from, to keep reactive molecules like oxygen, gas, and things like that away from the weld. That's it for this video. Be sure to email me or text me on Remind with any questions you might have. Remember, we have Zoom sessions on Tuesdays and Thursdays from 11 to 11:30. I hope to see you there.